Okay, so let's try to continue. I just lost the last video, so let's try once more. So welcome back. This is the continuation of the previous video. So after setting up the project, dependencies and stuff, now it's time to actually get started. So first of all, we're gonna create the most basic ever feature for our game, which is basically the health feature for a character. So whenever you need to create like a health component or something like that. So basically what we're gonna create now is like the health feature. So we're gonna increase, decrease health whenever we need it. So we're gonna be able to kill a character, but yeah, without the animations and stuff, but mostly focus on C++ coding and the basic. So right now, what I have inside the project itself, let me just show you guys. Basically what I have in the source code is I have the test folders, which is basically a folder. Yeah, there we go. We have like a test folder, which is where I'm gonna store my tests, the test for my project. I have like a game mode, components, and character folders, which is basically the game mode is the one that it comes by default whenever you create like a C++ project, but I just organize in a better way, like the header and the CPP files in public and private folders, so they can be more organized and less messed up as they were before. The same goes for characters. I just create that one playable, and that's the character that it comes up with the UE4. After doing that, I've just kind of regenerate all the files from the Visual Studio files, and of course I got a bunch of compiling issues because I changed the folder structure. But when you're using Writer, it's gonna show you like which line it's causing the error, and when you do that, it's just a matter of you're gonna see that's gonna be the game mode header file and the character itself header file as well. So it's just a matter of going back and changing the include to the proper folders that you saved up, which in my case was characters playable, and then the header file would be there. And the same goes for the game mode, which is now inside of a folder named game mode. So yeah, basically that's what I did. And inside of my project, I created already like the component called health component. You can create like a component based on just can just go to the public, whatever you want. Create a folder name component. I created a new C++ class, and that's going to be like an actor component. So that's what I did. I named it as health component, and that was it. The same goes for the tests for this health component. I created this health tests, and I also created I'm not sure why it's not showing anymore here. Probably because it's a private inside of a private folder, so that might be why. But I created as well like a inside of my test folder. If you can see, go back into the test folder, you're gonna see that there's also health component tests. Probably it's because it's private. That's why it's not showing up probably, or because it's an empty class. So basically what I did to create those is I created like a new C++ class, an empty one, and I named that one as a health component tests. So we can create our unit test for the health components in it. And the health test is basically a functional test, which is basically the one that's, like an end-to-end test. So I highly recommend to you guys when you're going to TDD on all project, you should also know that you're gonna write more tests than code usually at the beginning, at least until you get used with the flow. So basically, what you do, you create the files whenever as you need, and then you write the tests. They're gonna fail, and then you're gonna start fixing the tests and adjust the code, and making refactoring and working through that cycle. So that way you avoid as many bugs as you can in the future, because most of your tests are going to be fully automatable. So you don't need like any manual, testing or effort to test your game. And whenever something breaks, you're going to see on the session front end that the test is actually broken, and you might be able to go back into your Git commits and see which is actually the commit, and rolling back until you see where that bug was introduced. So you would know where and why and how to fix it, or maybe who introduced that, and send that bug to the person that I introduced it to fix it. So if you're working a bigger team, but yeah, so that's what I did. I created this health component, and I created two files, the two test files. That was basically what I did. And in terms of new files into the project, I already built everything. So I'm gonna present to you how I did it actually, but just so you can understand what's the flow of TDD and how to implement it in the UE engine. It could be UE4 or UE5. It doesn't matter. It's gonna be the same probably. So once you enable everything, set up like the dependencies as we did in the past. So basically what I did is I went back to my health component tests and I include my headers. So basically I included my automation test header. I include as well the automation editor header, which is basically the one that we use to spawn things and create worlds or loading maps or whatever. I also imported the health component and the test character. So basically, before even starting that, I inside of my character itself, I created this health component variable in it, and I created a default sub object as we usually did or came up with for the camera and the meshes or whatever. Basically, I just created like a default sub object of the type U health component, name it health component, and I imported as well the health component header, which is basically my health component, which is gonna deal all the damage. And then you may wonder why you're creating like a U health component and like a custom health component instead of just using the function that is built already on the actor class name. I think it's on take any damage. Well, that's why I don't want to rewrite code basically. So I create like a health component that can be used throughout the whole game, not only for my main player, but also for AI or maybe to some destructible object or something like that. I can just use that health component into the actor itself, into the blueprint or whatever I need it, and I can specify an amount of health, and based on that, I can destruct the object or kill the enemy or whatever. So I don't want to rewrite the whole thing. So inside of a health component, basically what it does, I separate basically 4 different tests or 4 different requirements. One of them is whenever I spawn the player, it may start with, the maximum amount of health because I shouldn't start dead, basically. So that's one requirement. The other one is the player health should never be negative. So that's basically because if you're creating like a UI or something, I don't know just yet how my UI is going to look like, but if it's going to contain like the actual number or like 100% or whatever, like a number into the UI instead of just a progress bar or whatever, I might, or maybe it might contain like the amount of hearts based on the amount of number that I have as a health. So a negative number would, maybe mess up my UI in the future. So I want to avoid negative numbers. So that's another requirement. And I won't be able to apply damage to anyone that is using this component. So it could be a player, it could be an AI, it could be an object like a destructible, whatever. I also don't want to increase health when I'm trying to actually decrease it. So basically is whenever subtracting something, if you're subtracting minus with minus, it's going to be plus based on the math rule. So let's suppose you want to try to, I don't know, 100 minus 50, it's going to become 150 because minus and minus is plus. So that's a math rule. So I don't want it to allow these exploit into my code and like maybe some cheat or something, like just a simple requirement. And also I want to be able to kill the player with this health component. So right now I don't have any, increasing or, recovering into the health component. It might have in the future, but right now I don't. So that's something to consider. Right now it's just a simple health component with the intention of applying damage, killing the character, and that's the basics. Really simple stuff. So those are the tests I created. And if you go back and how to implement tests, this is a macro for UE4 to implement a unit test. So you can implement simple U automation test. There's others as well, like complex or whatever, but this is the simplest one. So you're gonna need to create a name for your test. In my case, this one is F spawn. You need to start with an F by the nomenclature, basically. So F spawn player test, which is basically gonna be saved under the section gameplay health player spawn player. So it's gonna have like, if you go back to the UE4 and the session front end and the automation, you're gonna see that you're gonna have gameplay health player and Oliver test are gonna be there once you're specified that way. And then you're gonna need to specify the filter and the flags for your test. And if you go back to the automation header, the automation test header, you're gonna see that those are pretty much self-explanatory if you take a look at that. So basically, it's where you're gonna run it, like the application context required for the test. If you're gonna run to edit into the editor, it's gonna need to be run in a client or on a server, or the comment context. And the application context is basically, I mean, whatever. It could be any of those. So since I'm building this as a standalone game, not a multiplayer, I don't need to be worried about server or client. I mean, the the player could be the server, or the player could be the client. So I don't care about multiplayer at this point. So this is not intended to do any sort of replication. I could be just adding the editor because that's my main goal. It's just testing into the editor. I'm not quite sure what just yet is the commandlet, but yeah. So just for to be safe, I usually just to take the application context mask, which is basically all of them. But I could just use the editor context. But yeah, I select the application context. It could be just the editor, but whatever. I specified the how much critical is this test, like what is the priority of the test. There's others as well. So you can specify, for example, some sort of feature required for it. For example, if you need just no RHI for it, or if it needs to instigate a session, or if you want to skip the test, like disable the test into a filter, and yeah, like it sets as a disable by default. And also in my case, I don't care about those two, so I'm just gonna set up the priority of my task based on the requirements. I set it up what's critical, which is basically it's a showstopper or a blocker if it fails in my pipeline in the future. So you probably, if you're working in a big company, or if you're working, it doesn't need to be a game developing company. It needs any company that does software development. You're gonna have like a pipeline to run all of those tests. So that's how you prioritize your test. In this case, on UE4, you can specify the highest priority possible, which is critical, which is like a showstopper or blocker for the release of your game. You can specify high priority, which is basically like a major feature, or high priority above, median, low priority. And this priority mask, I'm not sure whether someone would use it unless they don't kind of care for priority, whatever, on that sense. Also, I need to specify the speed of my test, and that's where you need to be really careful with it. For example, if it specifies smoke filter, what it's gonna do is it's like it's gonna be considered for the engine like as a super fast filter. So it means like whenever you launch the engine, it's gonna try to run the test before actually launching the engine, because it's like it doesn't need the engine to be around, doesn't need to wait for to loading the engine. It's mostly like a unit test of some math functionality or something like that. Though if you need to spawn an actor or something like that to do so, don't use the smoke filter. Otherwise, your engine is not even going to open. It's going to be complaining of bad access, bad memory access, like null pointers, exception, or something like that. So only use like smoke filter when you know that you don't need like the engine behind to do the trick. The engine level test is basically the same thing, which is basically it's gonna be a test inside of the engine, like a specific engine test. If you maybe implement something, because Unreal Engine is like an open source library, so you can always go into it and implement some custom features to your version of your engine. So you can have like your customizable version of UE4 or UE5. So if you want to test something specific to the engines like itself, you can use this filter. Specific to the game itself, which is basically your product level test, you can specify product filter, which means like you're gonna need to have the engine behind loaded, in order to test it out. If you want to performance test, a stress test, or just like a negative test, which is basically like a false positive test. So, and this filter mask, I don't know why someone would use it, but again, it's something that is in here. It's just that I don't have the know-how on how to use it just yet for those. I mean, it's just I don't see the value on it just yet. But yeah, so once you define those tasks, it's time to you to actually write it. So you can write like in the TDD test, like this using the same name as you define, like as a bool function, run test. And well, for example, this is spawn test. I need to spawn the character and check if the health is gonna be the maximum one. So basically, what I do is I just go to I spawn my character, and then I call this function, which basically returns my health component. So I can, based on that, call these other two functions and actually test. For example, if you're looking and if you're familiar with other sorts of development or other sorts of automation, this test equal is most likely the assertions that you usually have on other frameworks. So assert equal, assert no, or assert true, whatever. You're gonna in UE4 it's gonna be, or UE5 probably is gonna be the same. It's gonna be test equal, test not new, or it's gonna be, instead of assertion, it's gonna be test. So basically, in this case, since I'm testing that whenever I spawn the player, it has the maximal health. So basically what I do is, this is the message that's going to be in if this assertion failed. And what I'm actually testing is that the actual value, which is the actual current health of the character, is actually the same value as the maximum possibility of health for the character itself. And those values inside of the health component, those are like two functions that only returns two different variables, basically. One returns health, which is basically the health, the current health, and the max health, it's something that is exposable to the editor. So basically, whenever you open up the character, let me just open up the character right here. So once you create the component and create the sub-default, create the default sub-object as we did, as I showed previously for the component itself. So if I open up the character itself, whenever you specify that health component creating the default sub-object with the name health component, it's going to have it like a new component in here. And this component is going to have like this max health variable in it, which is basically the variable inside of the component. I was looking at the character. So this max health variable, if you go back to the definition of it, you're going to see that it's marked as added anywhere, which means that it's going to be editable here through the editor. So you can specify like different values for it as a maximum amount of health. And whenever you start the game, the current health is going to be the same as the max health. So it's something that is going to fail on your side once you start it, but as soon as you get used to TDD, you're going to need to fix that task and refactor. So I'm going to leave like an article on how TDD works. For you guys, it's on Wikipedia, but you can probably just look for TDD and you're going to see how that works, basically. So yeah, so I create those tests, and for my initial test, it's going to fail. None of those functions really actually existed at the time, so basically would just create like an empty function, return like a 0 or something like that, and then refactor until I get used to it. And if it fails, it's going to say that I should start the player with the maximal health. So if I, instead of get the current health, set, I don't know, like 90.f, but it was at 100, that means that my value at the spawn was 90, but I was expecting the maximum amount, which was 100% of life. So, and then just destroy and return true. That should be about it. And the same go for the negative plus. So it would fail because I would be able to subtract, for example, if I had 100 as the maximum amount of health, or 200, you can change that. Remember, you can change that max health under the editor. So let's suppose I leave it as 100, and then I want to deal a damage of 110. That would be 100 minus 110, which means that I would have like minus 10 of health into my character. So what I need to do is, it would fail again, this test, but I would need to double check that it couldn't be negative. It should be at minimal 0 when I hit. So basically, if I get back to the deal damage function, clamp the value. So instead of just picking up the number and subtracting the damage, which would be 100 minus 110, I set up like the result of that, the minimum value should be 0. So if it's minus than 0, it's going to be 0. Oh, but it's, I don't know, minus 5, it's going to be 0. So it's going to kill the character and set the variable 0, basically. That's how I check it up, and I fixed that task once I did it. So this task now would pass because it's dealing the damage and guaranteeing that even though if I try to subtract more health than I actually have it, the current health is going to be 0. The same way, I just check that I can actually decrease the health. So if I subtract 50 of the health, I actually have the current health is the same as the maximum health of 50, less 50. So I can actually apply a damage to the character. And in the same way, I double check that I cannot cheat with my code. I cannot exploit that fault of sending a deal damage of minus 50, which is, again, if I go back to the health component, what it's going to do is 100 minus 50, it's going to be 100 plus 50. So it's going to be 150. So it would be increasing the amount of health of the character instead of, applying the actual damage, which is actually the intention of the function itself. So basically, to avoid that, I don't do anything if the value is minus or equal to 0. So into my tests, even though if I pass a minus 50, it's not going to do anything. So basically, the current health is going to stay the same. So it's not going to punish the player for trying to cheat, but it's just not going to work, basically. So you could apply some cheating, or you could apply some, anti-cheat test over here, but just to keep it simple, that's how I did it. And also, I double check that I can actually clear the player. So I have like a Boolean value inside of the component. So all of the state like life, alive or killed, the state is inside of the component itself. There's like a variable name is alive. So if the health is, after subtracting the amount of value, is either minus or equal to 0, I just set the b is alive to false, basically. And inside of my tests, I deal the damage of the maximum amount of damage that I can do it. So I basically zeroed out the life of the character. And I double check that is player is alive is actually false. So that function is only returning that variable itself, which is b is alive. So that's how I would create this component and unit test it. Though it doesn't mean that everything inside of the component is actually tested. Because remember, the component itself, if you go back to the component and actually double check the code, you can see that it not only returns a variable, but also in order to actually apply the damage, it uses this actor on taking the damage function. So if you go back to any actor, for example, this third person, and go back to any damage, you're gonna see that you have like this event any damage. So this is what I'm trying to say. So whenever an actor taking a damage, we need to communicate to the health component that this damage is actually applied. But this is not a component thing, so it's not possible to test inside of the, or it might be possible, but it's not ideal to test or mock the data to test this interaction within the actor and the component itself. So what I did is I create just for this specific case. Remember the testing parameter, you can double check that concept later as well on the internet. So the base of the parameter is unit testing. So you can unit test as much as you can and add as much as possible testing for your code as a unit test. At the top of the parameter, you're going to have like end-to-end test or UI test or whatever. Why is that? Why you should have less UI test or end-to-end test than unit testing? Well, that's due to the effort or time to actually execute those tests. And also, UI tests or end-to-end tests tends to be a lot flakier than the unit tests are. So because they might rely on environment variables or something like that, it might rely on machine processing power or external like internet connectivity or something like that. It might require on external things that are not actually controlled by the code itself, and some uncontrolled variables that might be added through end-to-end tests. So as much as you can avoid it, you should avoid it on automation side to do end-to-end tests according to the testing parameter theory. So yeah. So on that case, this would be my only end-to-end test, which is testing the integration of the actor with the component itself. So if you go back, what I did here is on the begin play, basically I just get the owner of the component. It could be my player, like the the fastball character. It could be any player, like an AI player, or it could be any other object itself. And what I did is I attached to the onTaken damage this dynamic function called handle damage. And the handle damage basically is, if you go back to the onTaken damage signature, basically what the handle damage is, it's the same thing as the onTaken damage signature. So you're gonna see that it's gonna have that same amount of variables, and that's because you need to have the same amount of variables in order to be able to dynamic assign a function to your component or even to your character. So if you wanted to bind a function, a custom function to an already UE4 event, like for example on taking a damage, or it could be on beginning overlap when you're triggering some or passing over through an area that should trigger something else. Instead of on taking a damage, it would be an event on UE4 name on beginning overlap. So you would do it this way. You're probably gonna need to grab inside of your custom code and bind or add dynamic your function with the same parameters to that UE4 event. So that's how you would do it. But we need to test that this onTake any damage, once it's called, it's actually calling our custom function, which is handle damage. And the handle damage is, assigned as the same way in order to work as the onTake any damage signature. But you don't need to use all of those parameters if you don't want it to. So basically what it is it just called the deal damage, which is basically what mostly we are unit testing. And I am broadcasting something for the level designers if they want to do something into the blueprint level. So if I go back to my health component, I created my own signature as well, like a health on health chain signature. And basically what it does, it sends to the blueprint level the health component if they want to, if they need to grab something inside of it. It sends as well if the player is alive. It sends what the amount of damage that the players actually took and what's the current health after the damage is taken. So, and once I set it up, this signature, I can just, create a variable behind it. And whenever I want to call it or trigger that event, I just want it to broadcast that signature and pass the parameters as I set it up at the top of my signature. So I set it up the U health component. So I send this if the variable is alive. So I send the variable, what the amount of damage, and the current health. Basically, that's what it does. And so if you want to create that event but never want to broadcast, because or maybe no one is using, you can just delete that. But what that basically does is whenever you click on the health component, you're gonna have like a new event on health change, and someone on the level, like some level designer or someone that's more familiar with blueprint coding than C++, then they can trigger this event. And this event will always be triggered when this handle damage function is already, pretty much done. So it's gonna call the deal the damage, and only then it's gonna call and broadcast after all of this process is done. It's gonna call this custom event. So the player could grab the health component, check if the player is alive, and do something, get the damage taken and current health, and maybe make some visual effects like some blood widget or something like that been popping up on the screen. So that's something that you may want to talk it out with your level designers to see if they want custom events over your components as well. So yeah. Yeah, that's basically what it does. So, but I need to test it out on taking the damage. Because otherwise, if that doesn't work, this add dynamic function doesn't work, we're gonna have the impression that our player is actually handling the damage and taking the damage properly, but they're actually not, because this on taking the damage is never being assigned to our custom function. We are testing our custom function, but we're not testing the integration with the Unreal system, the actor system. So we need to test this. And to test that, I created like a test map, since it's an end-to-end. So basically I'm gonna open the ftest health map. So what this map is actually doing is, basically I set it up a nav mesh bounds volume. I just drag it up from the nav mesh bounds volume, and then This is basically allowing me to move around any player or AI into this specific box. I drag it off as well a pain causing volume, which is basically this one. And it's causing, if the player basically what this does is if the player overlaps this for each second that the player is overlapping it, it's gonna take 10 of its health. So it's gonna trigger that on take any damage event. It's gonna take 10 of this health. So if you go back to the third person character, it's basically gonna trigger this any damage event, and this variable damage would be 10 basically. So if you want to do something manually on the blueprint level or something manually inside of the character, that's how you would trigger, at least in a simple fashion, just to test it out, this integration. So basically what I'm going to do is I'm going to make this character move around into the pain volume to force that on take any damage triggering. Though my character doesn't have any implementation, I'm going to open my character, it doesn't have any implementation for the on taking the damage, as you can see. So there's no on take inside of my character. So there's no implementation to take damage, though my character has this U health component, and the U health component is actually grabbing the owner, which is my character, and whenever this on taking damage is triggered, I'm actually calling my handle damage function. So I'm actually testing that my own taken damage is working and properly calling the function that I wanted to. So what I'm going to do is I'm going to move my character around and trigger that on taken damage and see if my health is being decreased inside of my custom component. So basically I'm going to move around. To do so, I drag it up my character itself, which is basically my C++ class, but a blueprint one. I look it up for possess, just so I can, oops, I think I look at the wrong one, possess, there we go. If you go to the pawn section, auto possess play, it would be set to player 0. I disable so no one would be able to possess the player itself. Also, I just put like some particles here just for the sake of, making prettier to look at. Also, I added this health test camera. So remember, UI tests or end-to-end tests, they might record video or they might show you like how things are done. So this is like the view that I want to look at, like where and how I'm gonna look at for my test. So if you're gonna see that, let's suppose I put here, this is gonna be my view of testing. So whenever I trigger the test, that's gonna be my view, like my viewport and my video, I would say, to see the test being executed. So yeah. So I just drag and drop like a camera to the place. I rename it like as health test camera, and then I create the actual test inside of my testing folder, which is called health test. So it's a functional test. It's a different class. It's not an empty one. You can show all classes and find out for functional test. That's the class that we're looking at. I just create that class, and let me just close it up, everything. So let me just close the unit tests. So basically what that does is if you go back to the health test, I have the constructor that I created. So inside of the health test, inside the constructor, I just set the timeout for the testing. So if it's executing for more than 5 seconds, it's going to time out and fail the test, which is more than sufficient to move the character from here to here. So it should be more than sufficient to cause the damage. The distance threshold, which is basically I'm moving the character from here to here, but doesn't need to be like exactly at the point of the exact FE vector location. It could be closer that to this area. That would be if it's inside of this pain volume, it's gonna cause the damage. So it doesn't need to be exactly in the middle or something like that. That's what I meant with the threshold. This is a try and error. I said it as 100, but you need to try and error to see what's the threshold acceptable for you. In my case was 100, but it could be different for you. It could be like 50, or I don't know, or you can just expand the pain volume. I mean, the intention is just to check if it's applying damage once the untaken damage is triggered. And on the begin play, what it basically did is, before actually going to the begin play, I exposed the blueprint level, the character reference. So I wanted to be able to grab a character. I wanted to force to have like a pain volume, so I can, trigger I can be sure that I have like a volume to go for. I set it up like an end location variable and a distance threshold. And with the exception of the end location, all of them are exposed through the editor and blueprints as well. But they are read-only on blueprints, and they are in the category named test data. I create the begin play and tick. But basically what that does is whenever I drag and drop that one to the, let me just delete that one. So if I delete that, drag and drop my class again, I'm gonna rename it to, I don't know, something functional health test. So that's my test, which is in the screen, and you can see that now under the test data category, I have player character, damage volume, and threshold, which is already at 100 because I set it up to be the default value at 100. And the time limit, if I go back, is also as a 5 seconds. But basically what I do is I need to specify the player character that I want to use as a reference for this test specifically. What's the volume of the location? What's the location of that volume? So basically I can just pick an actor from the scene. I can select my player. I can select also the damage volume from the scene. There we go. And the observation point, which is basically the view to see the test is running, I can pick it up my camera. And there we go. That's everything that I need to do in order to do my functional testing, to set it up my functional testing. And if I go back now on what's going to validate after doing so, I check if the player character, which is basically what I set it up, is not new. And if it is, I'm going to fail specifying that I need to showing a message that I need to specify a reference to the player. The same goes for the damage volume, so I can have like an end location to go. And in the begin play, what I did basically is I get the actor location for the damage volume. So let me just grab that one up before checking if it's no, otherwise it's gonna crash. So I check it up on the begin play. And after that, I get the controller of my player, even though I'm not controlling it. If you go back and look for controller, even though I'm not possessing the character, it has like an AI controller. And that's why the nav mesh bound volumes are required in this case, because I'm asking them to move like autonomously. So I'm not controlling it. Some people don't use the nav mesh, but they use like move forward or whatever. I don't think it's reliable depending on the kind of test that you need to do. So if you're moving just forward, yeah, sometimes you need to make curves or something like that. It's kind of a messy to approach that way. So I usually just create like a small mesh volume, and I can control the AI properly. And if the controller, if I can cast a controller, basically I use this blueprint helper library to ask the character to move to a location. So we use the controller and ask them to move to the location of the damage volume. So after moving it, if I don't have a controller, I'm gonna fail, say that I don't have a controller assigned to the player. But if after moving it, I need to keep checking once when do I get it to the actual location? When do I get to the location? And that's what I'm gonna do in the tick function. So basically, if I do have a character reference, I'm gonna calculate the distance between the current actor location and the end location. And based on that distance, I'm gonna double check if I can calculate the distance and checking if it's minors are equal to my threshold, which means basically if I got to the point that I needed to get. So if I got to the point that I wanted to, which is into the actual pain volume. So if that's the case, that means I should be taking some damage. And how do I check that? I grab my current health, which is under that component, and see if that's decreasing. If that's decreasing, that means that untaken damage is being triggered and is triggering my custom function inside of my component. So basically what I do is just grab the health component, and I check if the max health is bigger than my current health, which means that I'm taking damage. And if it is, I pass the test and quit the game. Otherwise, I just, quit the game and fail the test. And that's how it looks like in the real world. Let's just hit a compile, and we can show everything working just fine. You can see that there's more code for testing than actually for programming itself, like game mechanic. Game mechanic, if you can see that, just basically is that on taking the damage and the damage function itself, like the deal damage function. Though if in the future this project is gonna get bigger and bigger and bigger, I don't want it to, mess it up my character or any AI functionality whatsoever. So I don't need to manually test that anymore. I can just go to Window, Test Automation, and you're gonna see that you're gonna have like unit tests under the section that you specify. So if you go back to the unit tests, specifically you specify the sections over here: gameplay, health, player, spawn player. So that's how it's specified here. And the functional tests, they're going to be inside of the project functional test, ftest health, and you're going to see that functional test health, or functional health test, which is basically the name of the blueprint that you set it up. Let me just double check if that's actually there. I think that's the name, but let me just double check. Yep, that's the name you set it up. It's going to be there. So if you set it up, select the test that you want to run. Let's suppose you want to run not only the functional test, but you want to run all the unit tests first. You select your unit test, click on Start Testing, and there we go. All the tests pass. On your case, at the beginning, before evolving with your code, all those tests would fail, and you would need to refactor, go back, refactor your code until the point that it passed. And once it passed, you need to understand if the code is actually understandable, simpler, simple to maintain, and if it is, you're good to go to the next feature, or understand if there is any need for any end-to-end tests on that specific feature. But on that case, it's good to go. All of my tests pass because all of my implementations are working. And if you look at how many time it took actually to run those tests, those are ridiculous amount of time to run a test. Like for example, half a second, less than, I don't know, 1 millisecond. So that's huge. So half a second, 100 milliseconds, 77 milliseconds. So unit tests are pretty fast to run. So that's why they should be the base of your testing parameter. But if you go to the functional test now, I'm gonna run the unit test one now. I'm just gonna run the functional one. I'm gonna save it. No, I'm not gonna save it. Anything. You can see that it was really quick. I'm gonna try to show you again, but you're gonna see that the viewport, which is the camera, is now showing us the character spawning and actually running through the pain volume, taking a damage, and I can be sure that on taking the damage is called because once I check my component, the integration is working because my variable of health is being updated. But if you take a look at how many time it took to actually finish that test, and that's a simple test, it took almost 3 times more than any unit test took to finish. So if you trigger all at once, you can see the difference clear as day. For example, for unit tests, you ran 5 tests. You ran 5 tests in less than, I don't know, in half a second. Although with end-to-end tests, you ran only a single test, but 1.5 seconds. So it's 3 times slower to run that test. And that's because it's a simple map with just that information in it. If you have multiple testing maps, which is the ideal instead of having only one map with multiple tests in it. Otherwise, it's going to be a nightmare, and your test is going to take even more time to load and finish. So one map test per test per functional test in order to make as quicker as possible with less information as possible to run, only requiring the data set to run the test. And even though doing that, it's going to take 3 times more than any unit test. So yeah, so I have 5 more tests than this, and this is taking 3 times more to finish. So that's why end-to-end tests are the base, like the top of the pyramid, and the base test is unit test, because you can even guarantee the quality of your code and avoid bugs. But sometimes you cannot do that with unit testing. You need to do end-to-end, but you should do only when it's strictly necessary. Otherwise, it's just gonna take a lot of time to run your suite. And depending on how complex is the feature, more flaky and unreliable the end-to-end test might be. So yeah, well, that's how you implement TDD and how you run tests. And remember, in order to have this test automation too, and to work with the spawn or whatever, you need to double check the previous video where I set up the build config files. Otherwise, most of the functions are going to be complaining to you. They say, oh, you don't have this dependency or something like that. Yeah, hope you like it.